Dr. Mark Jangizi here through Science Moment. Today I'm going to ask who was more likely to fall into collective hysteria back in March of 2020. Who was more likely, the narrow experts with deep expertise or those that are masters of none with sort of broad but not deep kinds of expertise? Which one is more likely to fall into collective hysteria? And I mean, and this is sort of, we've talked a number of times about the kinds of forces that are involved in a collective hysteria, and I've talked before, almost 150 or so science moments ago about being aloof, and there's a number of reasons why I historically was aloof as a scientist, as a theorist, as sort of a grand unifying theory kind of person. In order to move from field to field, I always remained aloof for a number of psychosocial reasons that I was aware of that helped me make my way to new fields rather than just getting stuck in old fields, and then where I hope to have some kind of new grand idea, whereas I'm never going to have another grand idea in a field where I've already made a contribution. So, but there's a numbers of reasons why potentially some kinds of folks were more likely to fall into collective hysteria. And I'm mentioning these, and I don't have any good controlled experiments that says some of these are more explanatory than others, and some of these are not independent of the others. So, for example, the more one wants to be a generalist, the more one might tend to want to be aloof, and so they may often go together. And so what I'm going to talk about, try to get at a little bit more, is some intuitions about being a generalist, but of course, as I said, that tends to sometimes come with being aloof. But let me see if I could just focus on the more intellectual sides of being a generalist. And part of being a generalist, independent of all the psychosocial stuff, is that when you move from one field to another, into a third, into a fourth, into a dozen, into completely different disciplines over time, it allows you to see each time you enter two different things. Each time you enter a new field, you are looking at it from a very holistic perspective, often that the members within it, after being so many years, can't see that holistic perspective any longer. And two, you've been to so many other fields and are better able to see that sometimes what's going on in this field has some isomorphisms, maybe with the twist and all this, but there's sort of some kinds of similar principles that nevertheless apply, or similar ways of thinking that leads you to distinct principles, but the kinds of ways that one figured out, here's how to understand this in this other system, and I figured this system over here, and these ways of coming to understand or make a discovery help one in a new field. Those things make a theorist quite different, one who's a generalist, because they give them a different kind of tools. It's sort of a general toolbox that is good at attacking large-scale problems in different fields. And it's hard to overestimate, I think, the power of this. Now, I was just going to give you an example. So, for example, 20 years ago, 25 years ago, I entered a lab, and I had never done anything on visual perception before then. I'd done more neuroanatomy kinds of things, and theoretical why the brain is shaped the way it is, and lots of things along those lines, and other stuff, and why we have as many limbs and hands and fingers and across five. So anyway, there's a bunch of stuff that I worked on in philosophy and various things, but this was a perception lab concerning illusions and various kinds of things. And I realized quickly that the field was a mess. All that there was sort of butterfly collection. Each scientist historically had found their illusion, and they have another illusion named after someone else, another person, and there was thousands of butterflies just being collected with no large-scale principles, allowing one to explain why there are all of these illusions across all of these. And they had gotten siloed into their different regimes where they looked at really fine local mechanisms in the brain for why this might happen and why this might happen, and no one was sort of looking at all of these at once in a holistic way. So I ended up coming up with this sort of grand unifying theory. Well, first I came up with a sort of not a grand unifying theory. It was sort of a minor grand unifying theory, which was explaining all of these perceptual illusions which concern geometrical illusions. So a standard one is where you have two vertical lines, and you've got all these radial lines around it, and you perceive it to go like this. And I have a TED talk on this. And the idea is that all of these lines that shoot outwards radially are actually ecologically in the normal world. That means under normal circumstances, you actually get stimuli like this on your retina whenever you move forward, right? So this is, I don't want to get deep into the story, but the idea is that your brain needs to correct for the delays You need to not generate a perception of what was out there, but because of those delays, guess what the near future will be, generate a perception of that, because that way, by the time the perception occurs, you have a perception of that moment rather than a perception of the past. Anyway, in these ways, you can actually show why these things bow outwards, because as you move through the world, there's sort of particular non-Euclidean changes, which I'll maybe get these another time, but I want to get into the science of it per se. But what was interesting was that then led to a generalization in later work. I said, oh my God, look, that's just one kind of cue when you move forward. Sure, there's all these optic streaks, but there's all these other things that happen too. Things move more quickly as they're about to pass you versus moving more slowly when they're near your direction of motion. The contrast gets less contrasty as it's flowing outwards and really more contrasty over there. It's farther and it gets, of course, near. There's all of these different kinds of ways that tell you the direction that you're moving from stimuli. And there's all these ways that if two things are at similar distances, then depending on where they are, as you're moving forward, they're going to change in disparate ways, and you can show there's 4 different ways of that. Short story is that one idea turned out to generalize into a 7x4 table, which is you can see over here. It's a 7x4 grand unifying theory of 28 now classes of illusions. And in fact, when you scour the literature and look over thousands of paper in the perception literature, you can find that even some of these individual classes there's 28 classes, some of the individual classes would often have 6 or 7 distinct subclasses of illusions that people had separate little literatures about, and they never even considered them the same kind of illusion, but they're all within the same class. And so it was something like 50-something different subclasses of illusions in terms of their actual clusteriness within the perception literature. So you've got 58 different kinds of subclasses of illusions, all of which fit within 28 classes in this sort of 7x4 table, all of which have fundamentally the same explanation under my hypothesis. They're the exact same explanation. The stimulus suggests where I'm moving right now, and then on the basis of where I'm moving now, I need to generate a perception of how those stimuli will look in the next moment in about 1/10 of a second. You can explain all of those things with one hypothesis. And here's what amazed me. So first of all, this is the advantage of being someone who's outside, someone who's a generalist, someone who's a master of none, was that you can see this, right? And the reaction surprised me. So of course, there's lots of folks that don't like it, because if you're one of those 56 labs that has worked for 5 to 10 to 25 years within a whole sub-literature saying that this, going all these particular fine-grained explanations, then you don't want someone coming along and say, well, yours is just like all of these others, and the explanation that you're doing is not right. But one of these folks wrote a critique piece on this work and said, hey, you can explain this class by this other explanation that Doug over there has. And this other one that Mark says is explained by this grand thing, well, Judy over there has an explanation for this one. And this butterfly over here, Zach over there in this other lab over there, he can explain this with his other particular hypothesis. And he went on and on for pages about how there's 23 different hypotheses out there that can perfectly well explain these 23 cases. He didn't go through all 50 cases, just not much time in these papers. And so, this is an ad absurdum. And unbeknownst to this writer, this critiquer, this is an ad absurdum. The whole point of science, and this is what amazed me, is to be able to elegantly explain large swaths of phenomena, right? And to elegantly explain large swaths of phenomena, you want hypotheses that are incredibly general with a very small number of assumptions, and that are elegant and sort of functional. And so this is exactly what it was. You need to have a brain that corrects for its delays, and it has to understand the stimuli, and on the basis of the stimuli, it's got to guess what the world will be like in the next moment. And that explains all of these. And all of these concern forward motion is a very simple hypothesis. So his point that there's 28 different hypotheses by Doug and Judy and Fred and Zach and so forth that can explain all of these things makes my point. My one hypothesis can explain all 28 or all 56 subclasses of illusions, all with one hypothesis, rather than having 26 different kinds of hypotheses. And yet, for some reason, people who are experts get caught up in these micro explanations within this field and within that field and within that field, and get so bought into them that they're unable to see the larger picture, and furthermore, as it turns out, unable to even appreciate the fact that the very game in science is to look for these large-scale universal principles that cut across them. Now, I don't yet know the degree to which psychosocial issues of being within these communities makes this happen versus being a generalist versus an expert. But I do think this contributed to the to the fact that epidemiologists, by and large, most of them, or at least the ones that spoke up, public policy folks, so many of these supposed experts that came out and talked were totally all speaking the same thing. We're all on the same page saying, well, our expertise says that you should do this, and they all couldn't seem to back up and say, look, there's not just benefits. Even if the benefits that you are talking about work, even if it did slow transmission, or even which it didn't, which is what we said it wasn't going to do. But even if it did, to back up and say, look at the broad scale consequences of these interventions, these hypotheses that you have about interventions, you're looking at them in extremely narrow fashion rather than thinking about them in a broad scale way. And I am certain that kind of expertise, which is often encouraged systemically within academia, and it's unfortunate, academia ends up encouraging hyper specialization of this kind for numbers of reasons, and these hyper specialists just don't have a great experience with these large scale trade-offs across many different modalities. In order to understand the trade-offs of lockdowns or masks, you have to understand tons of different things. You can't just be an expert on filtration of masks. You can't just be an expert on cardiovascular in and out breathing. You can't be an expert epidemiologist. You can't just be. You have to understand psychology as well. You have to understand sociology, psychosocial stuff. All of these kinds. You have to understand perception because it's blocking your visual field. You have to understand lots and lots of different things, and you need to be the kind of person that is able to and experienced with approaching different kinds of topics and different kinds of fields that you may never have been in before, rather than having entirely spent your academic life, in public policy in one narrow field where you have expertise but no true wisdom. And that was your science moment.